This is gas stoichiometry, and it is going to be at non-standard conditions. Okay, we have a familiar reaction with butane and oxygen to make carbon dioxide and water. Our conditions now are 30 degrees Celsius and 1.9 atmospheres for the pressure. So no longer at STP, which is 273 Kelvin and 1 atmosphere. 15.7 grams of butane will produce how many liters of carbon dioxide at these conditions? Well, we're going to do a two-step stoichiometry for this. I'm going to start with my 15.7 grams of butane. I'll start it here. Remember to make sure you put your label on that. That's C4H10. We're going to do a two-stepper this time, and our goal in this two-stepper is to end with moles of what we're looking for. So I'm going to start with moles of CO2. So this step is always going to stay the same for this. We're going to have 1 mole on top of our C4H10, and we're going to put the molar mass here at the bottom, which I call the bakery mass. So that's going to be 58.0 grams of our C4H10. And since all I need to do is go to moles, my third step will not be there at all. So all I need is my coefficients in front of carbon dioxide and my coefficient in front of butane. So remember to put carbon dioxides on top. So I'll go 8 moles of CO2 over 2 moles of C4H10. And the answer for that comes out to be 1.08 moles of our carbon dioxide. Now we're going to use the equation PV equals nRT to solve for our volume. This is the ideal gas equation. One of the most useful things of this equation, it converts any moles into new conditions that are not standard. So I'm going to fill in my pressure, 1.9 atmospheres. I'm going to multiply that by an unknown V equals moles. My N is going to be the 1.08 that I just solved for by stoichiometry. I'm in atmosphere, so I'm going to pick the 0.0821 for the N value. Temperature is 30 degrees Celsius. Remember, you must add 273 Kelvin to that to get it in the Kelvin. So that's going to be 303. So now mathematically, I'm going to multiply these three together, and I'll divide by 1.9 to get my volume. The volume answer for this is 14.1 liters of carbon dioxide, and that will be at the conditions of 1.9 atmospheres and 30 degrees Celsius.